In this problem, we need to find all solutions in the interval 0 to 2 pi, which means my answers need to be in radians, of this trigonometric equation here. Well, the first thing you notice with this equation is that of the sine function on the left, the argument is 2x, and the cosine function on the right, the argument is just plain old x. So the first thing you have to do is you're going to have to use a double angle formula to rewrite the sine of 2x in terms of trig functions of x alone. So remember, the formula for the sine of 2x is the sine of 2x is 2 sine x cosine x. Don't be tempted to say the sine of 2x is just 2 sine x. Some students just pull this out, and that is totally wrong. You have to use the formula for the sine of 2x. So what I'm going to do is replace this with this expression here. So I've got 2 sine x cosine x equals the square root of 3 times cosine x. Now, what some students do on this at this step is, since there's a cosine of x here and here, is they divide both sides by the cosine of x. And unfortunately, if you do that, you're going to be throwing away some of your solutions. You won't see all your solutions. So what we want to do is get 0 on that side. So I'm going to subtract this from both sides. So I'm going to have 2 sine x cosine x minus the square root of 3 times cosine x equals 0. And now, since these both have a cosine x in common, I can factor it out. So if I factor out a cosine x, what's it going to leave me? 2 sine x minus the square root of 3. So here's my 2 sine x minus the square root of 3. So now I have two factors multiplied together equal 0. I'm going to set each of them equal to 0. So I'm going to have the cosine of x equals 0, leave myself a little room, and then I'm going to have 2 sine x minus the square root of 3 equals 0. So now we need to look on the unit circle and figure out when is the cosine of x equal to 0. Well, remember, on the unit circle, the cosine of x is the x-coordinate of the points. So the points where the cosine of x is equal to 0 are right here and right here. So the solutions there are x equals pi over 2 and x equals 3 pi over 2. So there are two of my solutions. And now on the second part, we're going to have to solve this simple linear equation here. So I'm going to add the square root of 3 to both sides, divide both sides by 2, and I get the sine of x equals the square root of 3 over 2. And remember, the sine of x is the y-coordinate on the unit circle. So we need to find places where the y-coordinate is equal to the square root of 3 over 2. That's going to be in quadrant 1 and quadrant 2. And here's my first value, and here's my second value. Both of those have a y-coordinate of the square root of 3 over 2. So in that case, my solutions are x equals pi over 3, my angle in quadrant 1, and x equals 2 pi over 3, my angle in quadrant 2. So how many solutions do I have for this equation in this interval? 1, 2, 3, 4.